Hello friends, welcome to BISPtrainings.com. My name is Amit and we are continuing building our HR analytical model in OBIEE. In today's session I am going to show you what are the scenario where you need to use physical database views in physical layer. I would also recommend you to view my previous video using custom defined SQL query to have a better understanding. Let's go step by step and see. So as we are building our physical layer, our complete HR data model, we are going to follow these steps. Step first, we would build our semantic layer, semantic data model using RPD. Step second, we build HR reporting and dashboard. The list of HR report and dashboards are available in your shared location. I'll also walk you through. And third step, we would facilitate our business users so that they can create on their own. That's called self-paced reporting or CAN report. So without any IT support, a business user can create self-service report. And step 4, we would design an advanced reporting and we'll be doing a predictive analytics with our data. Okay. This is a 4-step activity we are going to perform with our HR model. Okay. Let me go to the next level. So this is the objective of the complete training program, which we discussed many times in the past. We would understand HR dimension model. We identify the list of reports and dashboard which we are going to build for our customer. We identify the dimension, facts, joins, cardinalities, and simplify dimension model. So actually what we are going to learn today, it's part of simplification of dimension model. So why do we need to simplify? Okay. Let me show you the original physical model, which is a little difficult to understand, and therefore there is a need of simplification. This is my original physical model. If you look at like this, naturally you find it pretty difficult to understand and interpret, and therefore we use a concept called divide and conquer. We divide the model into small pieces and understand it step by step. That's exactly what we are going to do. So we split this model into multiple logical pieces and understand step by step. Okay. In today's session, we would understand the need of using database views in your physical layer. Okay. Let me explain you the requirement. So let me change this. My definition is called database views in physical layer. So my requirement is something like this. We have a table called employee dimension. We have an employee dimension. This is employee dimension, right? When I look at the sample data, this contains my employee personal detail, employee address, first name, last name, and other information. Now this dimension is pretty old, and this dimension has some data which is not relevant for BI reporting. Okay, and therefore we would like to filter out the data which is not required for my business. And I like to simplify the view to my end users. So unwanted, unnecessary data, I like to filter it out in my physical layer itself in order to simplify my report developer job. This is very often. This happens very often. So the suggested approach is to filter the records during your ETL process called extract, transform, and load. Okay. You can transform data and filter out the data which is not needed for reporting. But sometimes it is not feasible or not appropriate to filter out the data in your ETL layer. All BI reporting tools allow you to filter records in your source system as well as in your reporting layer. There are multiple ways to solve this problem. Today we are going to see how to solve this problem by using database views. So our requirement is something like this. We would like to bring only those information from my database where employee is active. Employee is active or employee is still working, which is considered as employee active is called over here. Let me use my marker. Seems my marker hang up. Okay, so my requirement is like this. I like to bring only those information from my employee table where employee termination is null. It means It's another way of saying employee is active. Okay. If employee termination date has some value, it means employee has been terminated. Employee is not terminated, employee is still active. There's a column called active indicator equals to 1, right? Let me show you these two columns first. So when you query your data, you may find some record. Right click and view data. I like to filter out the records where there's a column called employee indicator. Active indicator is 1. It means employee is still active. Okay. And there's another column called termination date. Termination date should be null, which say employee is still working. I want to bring only those records with employee status 1 and termination equals to null. Termination date equals to null. Okay. In addition to this, we also like to bring only those records where employee label is 3 to 6. It's like an employee band, right? So what is band 1? This is level of hierarchy. Like at band 1, your CEO at band 1. Okay. It's an employee reporting hierarchy also. At band 2, we have got CFO, CTO, okay, CAO and CMO. Chief Executive Officer, Chief Technical Officer, Administrative and Management Officer. So the kind of report we are going to build, it is not applicable to my CEO and CTO like benefit and compensation tables. So the kind of report we are going to build, we would like to exclude these employee band. And in order to do this, we are applying two level of filter. Employee level and employee position should not be equals to this value. It should be a combination of filter. Employee level should be 3 to 6 and position should not be CEO, CTO and CEO and CMO. Okay. In addition to this, we would like to only cater or query employees who have been hired after 2005, because before 2005 we have a different HR policies, and therefore the kind of report we are going to build for compensation and benefit applicable only for the employees who hired after 2005. This is my business requirements, right? So I like to filter out the record and then before we query. So let's see how to do this. There are multiple ways of doing it. I'm going to show you the smartest and simplest way of doing it. Okay. So let's do it once again. What I'll do, I'll delete my model and prepare once again from beginning. Okay. Let me delete it and do it once again. So step first, I import my physical layer. Step first, I import metadata. Step second, I will simplify the physical layer, and at the same point I'm going to use database views over here, right? Let me do it. Let's first bring the metadata. Import metadata. I'll be using Oracle database, so I use Oracle connectivity interface. My SID name is ORCL, username is HR model, and password. I've already shared this model with you, so you can do exactly same example what I did. And I like to bring table keys and table key and foreign keys. Okay. Click next. Okay. Now in the first example, I'll bring all the tables pertaining to employee. Okay. And as we proceed further, we'll simplify this model step by step. So I'll bring all the table of employees, all employee tables, drag and drop. I'll go by default properties in the beginning. It takes some time to import metadata. Perfect, I got the metadata. Now I finish. I'll see my entire model. The best way, right click and look at the physical view of it, physical diagram. I look at this is my complete physical model. Nevertheless, to say looks pretty complicated and difficult to interpret in one go, and therefore we simplify this model. So let's focus on the query, what we want. Let me save it first. We would like to bring or filter out the record with this given criteria. Sorry, let me minimize it. My criteria is termination date should be null, employee should be active, employee level should be 3 to 6, hire date should be 2005, and employee position should not be one of these, right? Let's go. So I find all required information in my table except one. Let me view data. Okay. So what information? As per criteria, I see employee active indicator equals to 1. I see employee level should be between 3 to 6. I find over here. I also find employee termination date should be null, and the hire date should be greater than 2005. Date hire should be greater than 2005. But I don't find one column over here which call employee position. Employee position you find in another lookup table, that is called employee lookup table. Another alternate and simple way of doing it, you can look at only physical table and direct join. When I look at the physical table and direct join, I see employee table is joining with my employee position lookup, right? There's a direct join, and the joining criteria is employee position code, right? When I look at my employee position lookup table data, sample data, it helps me to understand. Right click and look at some sample data, and there you find the positions are given in multiple language. So far I assume we are working on English language. So this is my employee positions. I don't want to bring table employee position who is CEO, CFO, CTO, CMO like this. Except those positions, I like to bring data for all positions. Okay. So the problem over here, I cannot use custom SQL query because data is coming from two tables, and therefore we use a view. Let me show you live what is the problem. If you're good at writing query, you can write query on your own. If you're not good at writing query, let OBIEE do it for you. OBIEE will render query for you and will use that query as a custom SQL query, and then we see the error message. Ready? Let's go to our model. Okay, let me refresh. Because we made some modification of physical layer, it's a good idea to refresh it. Now what information we need? Let me bring it from employee. We need employee records where couple of column I drag and drop, where employee indicator is 1, employee active indicator is 1, employee hire date should be greater than, I apply filter, should be greater than 2005. But if I look at my date, it's in date format. I need only year, right? So I'll customize this. I'll extract year from the entire date. Okay. You can go to function. There are many simple functions given over here. I can use date function, and there's a function called year. It's pretty simple. When you select on year, you find over here expression, and along with what does this function return. I take year, and this function return, I'll pass argument employee date as an argument, and therefore this function will return the year for hire date. From hire date it will return year. When you look at, you find only years. So I need greater than 2004, right? I want all year from 2005 onwards, so greater than 2004, right? So I apply second filter. A third filter is employee level should be between 3 to 6. I say employee level, I apply filter, between clause, between, okay, between 3 to 6, right? That is also good. And then finally, my employee position should not be CEO, CTO, any one of them. So employee position I don't find over here. I need to bring the employee position from my employee position lookup table where it's in English, the position EN, and then I apply filter over here. Okay. It should not be not equals to CEO, CTO. I give you a couple of examples, CEO, CTO, and so on. Okay. So this is what my filter 1, 2, 3, 4. 1, 2, 3, 4, and termination date equals to null. Okay. I forgot. Termination date equals to null. So employee termination date. I use custom SQL query over here. Filter. Convert this to SQL query is null. Okay. Right. My query got prepared. I just click on result. I got the data. And exactly we don't need a data over here. I need a query. So go to administration. OBIEE has rendered physical query for you. Go to manage session. Scroll down to your last and capture your physical query. Look at this. This is my physical query. This is exactly what I wanted. This is exactly what I wanted. Right? Before you copy this query over here, and before you use this query in your OBIEE, I would recommend you to use this query in database and test it. Copy this query, run in your SQL, and test it is running on working or not. Perfect. The query is correct. Right? I can't use this query as it is in a physical layer. If you are not sure, let me show you. Unlike in previous example where I right click and go to properties and convert this as physical database to custom SQL and paste the query over there. I could use custom SQL query in a previous example, but I cannot use now. Right? When I right click and test it, view data, you might find some error message. So custom SQL is not capable enough to bring data from two tables, isn't it? And therefore here custom SQL cannot be used. We would be using views. Okay. The simple way of using views. So what I do, I create database view, right, and use it over here. So I'm just giving an example. Though the entire view would be little different then. I write create view, view name, VW, employee, and position as select query. And your view got created. Right? Now rather than using these two physical table, I would be using views. Now what I need to do it, I need to import my metadata once again, and this time I would be using view. SID name, username, and password. Right? When I create view, I did not bring any keys. Okay. So check this option, table, keys, and view. Right now I need to bring only view. Okay. I bring view. Which view? From my HR model, VW, employee position, isn't it? And now you see the view over here. So rather than using physical custom SQL query, you can use a view. I don't need to use employee dimension and employee position lookup. I could use a one integrated view over here. Okay. The view which we created may not have a join directly, but what you could do, wherever employee dim is used, I can replace employee dim with my view. I can drag and drop the employee view and replace with this employee dim, isn't it? I did not do anything in this. I don't have keys. Also, if you look at carefully, the abbreviation or names are being used as C1, C2, C3. Ideally, what you should have done before you create a view, you should have replaced this alias name with the real name, like active indicator, address 1, address 2. In addition to this, you should also have a keys like In this dimension, what are the keys we have? We have got primary key. We need a key to join with other tables. Like we need to have an employee key in the view. We need to have position code also in the view. We need to have termination code. So whatever key is being used in this dimension, I could use in a view as well. So the moral of the story, when it is not possible to use custom defined SQL query, you can create database views and replace with your physical table. And this way you can solve a complex problem. Another beauty of using database views are a database object and you have zero administration and maintenance. Everything is done by database team. Unlike in your custom SQL, if your underlying metadata change, you need to manually modify custom SQL. But this is not the case with custom defined views. So that's it for today. Do watch more videos about HR analytics, how to build a complete HR analytical model using OBIEE. Should you have any question, you can write to us. Our email ID is, and you can visit our site called www.bisptrainings.com. Thanks for watching today's video and have a great day ahead.